All right. Hello, everyone, and welcome to another episode of the Logz.io training webinars hosted by the Customer Success team. My name is Adam Kazas, and I'm a Customer Success Engineer here at Logz.io. Today, we will be talking about advanced Kibana visualizations, and we're going to build a dashboard live, and we'll see some use cases of our champions. Before we dive into today's session, please keep in mind that you can always reach out to us 24/7 via the in-app chat icon that goes to intercom that is visible at the right-hand side of the Logz.io web UI and is staffed by full-time Logz.io engineers. You're also free to submit a support ticket by emailing us at help@Logz.io. In addition, you can find our self-support portal at support.Logz.io. This webinar, as well as our previous webinars, can be found at our Logz.io Academy, which is a self-paced online learning platform. So if you missed our prior webinars, it is available for you there, along with other resources like ebooks, how-to guides, and a lot more. Today, we have two exciting announcements to share. Last week, we have released our official Logz.io Slack chatbot, Alice. Alice is a chatbot who lives in your Slack workspace. You can ask Alice to perform Elasticsearch queries, see the alerts triggered in your environment, and get snapshot of Kibana visualizations and dashboards, some of which we will learn how to create today. You will find information on how to integrate Alice at docs.Logz.io, which leads me to our second announcement, our overhauled documentation portal, where you will find more information about Alice, as well as any information related to our platform. So we're ready to dive into today's webinar. Joining me today is two of our champions, Shachar, who is a General Manager and Director of Data Platform at Origami Logic, and Ryan Morrissey, Senior Director, Product and Strategy, Cloud QM at 8x8. Please introduce yourself, guys.
Hello, guys. As Adam said, my name is Shachar David, working at Origami Logic. Happy to be here.
Hey, everybody. My name is Ryan Morrissey. I'm with 8x8, managing our Cloud QM product, dealing with call recordings and quality management in the contact center.
Thanks, gentlemen. Good to have you here. So, in terms of agenda, we're going to talk about the benefits of visualization, showcase some advanced visualizations and features, build an operational dashboard, and check out our champions' use cases and see how they leverage dashboards in their day-to-day. So let's give a short recap of the previous visualizations webinar that we had. So why even use visualizations? So visual representation of data is easy to grasp. It will be much easier to find problematic spikes in a visualized way rather than through text. It's easy to scale, so no matter the number of logs that you send, Kibana will aggregate the data for you. It's efficient for troubleshooting, so mainly at the initial parts of an investigation or either at the end of them. And multiple sources of data aggregated to a single dashboard means you can create an overview of the health of your whole environment, including different types of logs in a single dashboard. So you probably ask yourself one or all of the following questions at any given time. What is the health of your system? What environment is affected? What geolocation is affected? These questions are usually a part of a greater question. What is the root cause of the issues that I'm facing at the moment? So I would like to take a moment and see how familiar you are with Kibana visualizations, and I will do that through a poll. I'm going to launch the poll now, and we'll wait a couple of minutes for everyone to answer the poll. So we already have above 70% voted. We'll give it a couple of more seconds. All right, so we're about at 90%. Let's close the poll and share the results. So it's pretty much mixed. We can see that most of you guys created a few dashboards and visualizations, so that's cool. And with that, I guess we can move on to our presentation. All right. So what we're going to talk about today as well. So we're going to talk about the importance of aggregation order. So the date histogram coming before the field aggregation and vice versa. We're going to discuss about the gauge visualization and something called average bucket aggregation inside of it. And we're going to talk about filters, using queries inside the filters to clean up your data and filter it. So without further ado, let's jump into the Kibana dashboard, and we'll take it from there. So the first thing I'm going to show you is, sorry, not this one. I'm going to talk about the bucket aggregation and why it is important for us when we create visualizations. So I'm going to start off with giving you the official term for what bucket aggregation really means. So bucket aggregation don't calculate metrics over fields like the metric aggregation do, but instead they create buckets of documents. In other words, the buckets effectively define document sets. In addition to the buckets themselves, the bucket aggregation also compute and return the number of documents that fell into each bucket. So I know this sounds a bit complex, so I guess the best thing we'll do is just show it to you in Kibana. So what I created here is a simple line visualization. I'm going to go ahead and create a date histogram. Click on play to apply it, and now we basically have just a normal count of all the logs. I'm going to create a second aggregation now, and I want to see the URLs that enter my website. So I'm going to use a field called request, and I want Kibana to keep an order of the top 5 results that I have. I'm going to click on play, and as you can see on the right hand side, I have way more than 5 results. So why did this happen? Basically what Kibana does at this moment is it creates different buckets of automatic intervals, and we can see the interval it created right down here. It says 30 minutes, and then it returns the top 5 results of each interval. So basically we see the top 5 URLs every 30 minutes. But check what happens when I switch between the order now of the aggregations and click on play. So now we actually get the top 5 results. So this is what I meant when I said that the order of buckets matter for the results that we receive. So this is not necessarily a good or bad thing. It basically means that you can get different results depending on what you want to achieve. If you want to achieve just the top 5 regardless of the time frame, this is the way to go. But if you do like to see a top 5 for each interval, then that's the other way to go. So now that we understand how the buckets work, I'd like to continue and show you the gauge visualization. So I'm going to create a simple gauge visualization, and I would like to see the Apache access logs that I have, and as well as to see only the 405 up to 599 response code. I'm going to click on play, and we get a simple count. So by default, the gauge will open with a count aggregation. However, I'd like to see an average aggregation over time. But as you can see, when I change the time picker, if I'll pick the 4-hour one, the count will drastically change. And this is not what I want to achieve when I look at the overall health of my platform. So there is something called average bucket aggregation. Once I click on the average bucket aggregation, I'll get populated with a new aggregation type that is a date histogram with an automatic interval. So I'm going to choose a custom one, and I'm going to set it to 10 minutes. Once I click on play, the gauge now will act as if there is 10-minute intervals across the whole time picker that I have, and it shows me the count of the logs that come in through my queries. So this is a good indication to see how many logs I had at a given time, and not just an average of a number. So with that, since I'm familiar with my logs, I would also like to change my ranges. So I would consider the green to be between 0 to 10, yellow between 10 to 20, and the red between 20 to 50. Once I click on play, you would see that the color scheme changes. Now I'll also give it a bit more orange color just to be more indicative. And this is about right. So I'm going to save this one since we're going to build a dashboard later on, and I'm going to use it in that dashboard. So we'll call it 20 minutes, average 400 and 500 gauge. I'm going to click on save. Now, in addition to this, I would like to get a contrast and see how many response of 200s I get, just to understand if my operations is healthy or not. So I'm going to change the query. And now, basically, as large as the number would be, that's a good indication for me. So the red color doesn't really fit. So for this, I would need to reverse the color scheme. And you can do this through this option right here. So once I click on play, you would see that the green will take the left side all the way to the other side. And with that, I will also change the numbers that I have of the ranges, just to make them a bit more in line with the logs that I'm sending. And this looks about right. So I'm going to save this one as well. This time I'm going to change the name to be average 200. And I'm going to save it as a new visualizations because I don't want to override the previous one that I created. And with that, I would like to show you another tip that we have, something a bit more advanced. Within almost all of the visualizations have this type of aggregation, and it's called the filters. So basically, what I want to see is what kind of operating systems enter my website. So let's first check out what kind of operating systems enter. So I will use the OS term aggregation, click on play, and this is the results that we get. So we have pretty much, first I would like to see it on type Apache Access as well. Not like this, apologies. All right, this looks good. I'm going to change this to top 7 just to make sure. All right, so this is the results that I get. So basically, I see that I have 3 types of windows. Now, I don't really care if it's Vista, XP, or 7, and I basically want to clear up the noise that I have in this kind of log. So what I want to do next is show you how you can do that using the filters aggregation. So the filters aggregation allow me to actually write Lucene queries inside the filter itself. So what I'll do here, I'll pick up a query that asks for windows with a wildcard at the end. This wildcard would pick the 7, XP, and Vista. Let's see how that works. Once I click on play, the other results disappear, and I'm only left with the query results itself. Now, you could also label this, since we don't want to keep the nasty query in my dashboard, and I'm going to label it Windows. And now I'm going to add the remaining of the results that I would like to see. So the next step would be anything with iOS in it, and I'm going to label that with iOS as well. Click on play, and we can see it pop up. And the third one, I just don't care about any others. I would like to see only the other ones. So I would write a query that says not Windows and not iOS. I'm going to label that as other. And then it pops up as well. So I'm going to save this for the future dashboard that I'm going to create. Let's call it 20-minute webinar, OS table with filters. All right, so with that, I'm going to continue and create more and more visualizations, and then I'm going to show you how to compile all of them into a single dashboard. So let's continue, and the next one I'm going to create is a heat map. Now, the heat map is a good visual representation of any kind of data that you want to see. So with the heat map, I would like to see the type of URLs on a date histogram that enter my website. So I'm going to create the date histogram first, arrange it over time. And on the y-axis, I'm going to choose the field request. And I want to see the top 10 URLs that enter my website. Oh, I need to switch between the aggregations first. All right, so this is how it looks. And basically, you can see a visual representation of the number of hits for each URL, and its order is descending with the one that's getting hit most all the way down. Now, I don't really like the color scheme of this one, so I'm going to change it to a bit more yellow and red. And also, I'd like to have more granularity in the colors, so I'm going to add 10 number of colors. Now we can see that we have a bit more visualized way of the way that the URLs are presented. So I'm going to save this one as well real quick, and we're going to call it 20-minute webinar heat map. Let's call it Apache heat map, so I'll know that it's Apache. So with that, I'm going to continue to the next visualization, which would be some donuts. So with a donut, there's a nice way to aggregate two kinds of data on top of each other. So the first one, I would like to know what kind of browsers enter my website. So the name of the website, gonna create a top 10. Not forget to look only for type Apache Access. Gonna click on play, and I have a visual representation of all the different browsers that enter my website. And on top of that, I'd also like to know the version. So I'm gonna add a sub-aggregation, and the field name would be major. I'm gonna click on play, and you would see that on top of the browsers themselves, we have the version. So in this example, we see Firefox, and then version 9 of Firefox and version 10 of Firefox. Now, as I've said, I want it to be a donut and not a pie. So I'm going to create this as a donut. And I'd also like to change the legend from right to left. And once I build a dashboard, you'll understand why. So while I have the donut visualization open, I'd like to, I'll save it first, of course. Then I'll create a new one because I still need the same visualization. All right. So next, I would like to see the kind of devices, and I'd like to show you another interesting trick there. So I'm going to change the name of the field here to device. I think top 10 would be enough. Yep. So we can see that we have pretty much 3 devices and then just unfamiliar ones. And this one really just takes a very large portion of my donut. So there is a neat trick here at the advanced section where we can exclude and include results. So I'm just going to exclude the other result to be left with the ones that I care about. And I'm going to save this one as well. I'm going to call it device, save as new visualization, and I'm going to change the legend position of this one to the right side. I'm going to click on save. Okay. Next up, we have the coordinate map. So you might be familiar with the coordinate map where it shows you a map. Just keep in mind that if you don't have geolocation enrichments in your log, it's part of our service and we can help you add this kind of enrichment into your log. So don't hesitate to ask that from us from our support. It can easily be done. So I'm going to go forward. I'm going to select the field, GeoIP location, and we can start to see some circles around. I'm going to look for type Apache Access as well. And in the options field, I prefer a different way to look at this kind of map. So instead of the scaled circle markers, I'm going to choose the heat map. Once I click on play, you see it looks a bit blurry, and we're going to fix that visually right now. So I'm going to change the radius to be something like 10. The blur, I'm going to somewhere around 8, looks good. Zoom should be about around 1, and the opacity around 0.50. Yep. Click on play, and it's a bit more dense now, and I feel like it's a bit more compelling to my eyes. I'm going to save this one really quickly as well. And let's move forward to the next one. So I'm going to create some tables now. I would like to have a correlation between the URL and the response code that my website is getting. So as before, I'm gonna say type Apache access. I'm gonna split the row. The first one would be the URL, which is called the request, and the next aggregation will be the response code. Okay, now as you can see, we have the 200s here, and I don't really care at this moment about the 200s. So I'm gonna add something to my query where the response is only between 400 to 599. And the top 5 looks okay to me. I'm gonna click on save. 20 minutes. Change the name to URL table. Click on save. Now I have a few more visualizations that I already prepared up front because there's nothing new that I can show there, and I would like to show you now how I arrange all of this into a dashboard. So let's go ahead, create a dashboard, and start adding at the right order all the visualizations that I just created. So first up, we have something called Markdown. You know what? Let me show you that real quickly. It's a nice tool for you to manage your dashboard in case it has multiple sources of data. So the Markdown is basically just a text box. You can also check the Markdown syntax over there, but there's a way to make headers and subheaders. So let me just show you one of them, and this one would be for my Apache Access logs. I'm going to create a subheader here, just a description. Click on play, and basically this is what we get. We get a header, and you can any kind of text you can write up here. You can add images and so forth, and this can definitely help you make your dashboard a bit more arranged. So we'll go back to our dashboard now, and let's start adding the visualizations. So first I would like to add the Markdown that I had, and I'll arrange that. In addition to that, we want to see the line chart. Where is this line chart? Okay, I'll get to it later. So let's start with the OS. We have the browser donut, we have the device donut, we have the heat map, the GeoIP. We'll get to the metrics soon. It's probably on the next page. Oh, we have the gauge. All right, this looks good. I'm gonna arrange it right now, make it a bit more appealing. So I'm gonna take the heat map, I'm gonna look it over here. I just want to make it logical, the way that I look at the dashboard, and it would make sense to any other people that look at this dashboard. I'm gonna shrink these ones, grab this one over here. The table doesn't belong here, so I'm gonna take it down here. Same with the gauges. So as you can see, it doesn't take long for us to have an operational view of the data that we just created. We don't really need the legend for these ones. You know what, this error bothers me a bit, so let's take care of that as well. So we got an error where the data was too long. So we're going to create a custom table here. This will change the text over here. So this one would be the average 400 to 599 over 10 minutes. I'm going to click on save. And once I go back to the dashboard, it should be visible now. Much better. I'm going to save this dashboard right now just to make sure. And I'll do the same for the other gauge as well. So let's give that another custom label. This one would be an average 200s over 10 minutes. I'm going to save that as well. And once I go back to the dashboard, it should already be populated. So as you can see, we already have sort of a nice graph of our health. I'm still missing 2 tables. So let's add those as well. So it was called Apache line chart. And this one should actually go over here. I think the heat map should be above the map. We'll shrink this one. And the final piece of the puzzle would be the URL table. I'm going to shrink that as well. Put it right here. So there you go. This is a fairly simple but effective dashboard that we just created. Now, I'd also like to add some more visualizations into this one, and then I'd like to showcase you how we can actually find an issue in our logs only by using a dashboard. So let's do that very quickly. So I have some metrics that I created before. With CPU, memory, and some gauges. And I'm going to arrange them as well, because at the end, if it doesn't look right, it's really hard to work with. So let's move these around a little. Play with this. Okay, so this is something called the Visual Builder. We have the CPU total gauge over here, as well as CPU over time. We also have the memory used over here and the memory used against the total memory that we have here. And as you can see, I labeled this as metric logs underneath. And another thing that I would like to add is the backend logs that we have. So we have the backend markdown, we have the exception details, backend logs, and also to keep this even more simple, we're going to add a saved search at the bottom of this dashboard where we'll actually be able to see the logs themselves. So let me just arrange this really quickly, and that will be the end of the arrangements. So now we have all the logs. We have backend exception details, backend logs. We have a metrics section, and we have the Apache section. So let's save this very quickly and go ahead and see how we can find issues and the root cause within our log. So just from a very first glimpse of my logs, I can definitely see there is a spike here. So even before I zoom in or anything like that, I can have a look at all of the metrics over here and find if there's a problem. So obviously the first one that comes up is this bump here in the 504 error logs. So I'm going to take my mouse, I'm going to zoom on this section. And when I do that, the time picker will change and all the other visualizations act accordingly. So I'm going to zoom even further to the exact moment of the peak. And only by the gauges, I can see that both of them have turned red. And red is obviously bad. Now, in addition to that, I can see that it's not something specific to any kind of browser. It's not specific to any kind of device. It's not even specific to any region. It looks like it's been global. I can see all the operating systems, and I can see a number of links, but the main one that pops up with 504 is the cart one. So it means I'm losing money, actually. So when I even scroll down further to the metrics, I can even see that the CPU is getting tired. The memory used is all the way up. So I want to find out if this is something in my backend as well. So the next step I'm going to take is I'm going to filter in, the warning logs that I have. So once I do that and I start browsing through the logs themselves, I can see that there's a lot of transaction aborted. However, this still doesn't give me the root cause of what I'm looking for. So if I look at the exception details themselves, I can pretty much guess that the large portion of this pie would be a symptom, and I would like to find the root cause. So it's possible that this small sliver here is the root cause. I only need to click on that once, and there it is. I can see a Spring Frame Network exception coming up. And from there, I can do all the things I need to do in my backend to fix that problem. However, this is how I managed to find all of this only by using the dashboards. So with that, I would like to move forward and give our champions a chance to show their actual use cases from real life. So Shachar, if you can take that from here, I'm going to hand you the presenter. So Shachar, take it away.
Yeah. Hello guys, and thank you, Adam. So before I begin, I want to start by introducing myself. My name is Shachar David. I'm the general manager and head of the data platform at Origami Logic. Couple of words on Origami Logic. Origami Logic, if I try to simplify it, we're basically selling analytics data to marketers of large brands. And as such, we're dealing with a lot of data. But before I dive into Kibana and show you real examples, I would like to tell a short story about our experience with specifically the ELK solution and our experience with it. So I joined Origami around 3 years ago. At that time, we already had paying customers. And one of the challenges we had is to find issues before the customer are seeing it. And it was super important, especially for a company that deals with data. Customers losing interest very fast if the data is not reliable. So to do that, me and my colleagues, we quickly understood that we must improve the visibility of our system. So basically, we decided to spin up an L cluster. And after a month or something of that sort, we released a version that basically shipped logs. Each logs was basically a JSON line to the L cluster. And right after, in I don't know, in around a week or two, we figure out that we have so many issues because of this visibility. We fixed them, but it wasn't good enough because we wanted to basically be notified and basically proactively fix issues, especially because we wanted to fix issues before the customers are seeing them. So to do that, we actually used another open source, ElastAlert, which is basically an alerting system on top of Elasticsearch. At some point, we decided to move to Logz.io. One of the reasons, beside many, was that it was high maintenance. We had so many issues with Elasticsearch, and from upgrading the cluster, I don't know if we have Elasticsearch folks here, but every time we upgraded the version of Kibana or Elastic, we had different issues because of lack of backward compatibility and so many other issues. So to make a long story short, let me share my screen and I'll show you some of the dashboard we use. So just a second, I'm new to that app. Yep. So hopefully you can see my screen. Yeah. So this is a dashboard which is based on the instrumentation of all our API endpoints. So imagine what we had 3 years ago. We had many APIs that support many things, and as a startup, we build so many endpoints. You grow, you change your focus sometimes, you build new APIs. We didn't have a centralized logging system to find all the issues that we had, so we basically back then went to the servers themselves to actually look at the logs and understand what happened. Over time, we moved to Docker. It was very straightforward process, but it helped us to also centralize the logs. Since then, since instrumentation, we could basically see everything that's going on in the system. For example, the number of teams, or teams is basically customers that are using our APIs. This is based on staging environment, so it's less exciting, but imagine what happens in our production environment. The number of services that are being used, how many endpoints, how many API calls were made to our endpoints, how many failed, latency, average latency. I cannot see that part, but you can see that, so it should be latency. Hopefully, I'm not wrong. So one of the most important things that we actually look at every day, and this dashboard is just one dashboard out of many, is basically error trends. We're trying to release a version sometimes every day, sometimes several times a week. And one of the most important things to look at is basically the error trends. We had many times, especially in the past, now it's much better, that we released a version and something broke and we didn't even know about that. So these error trends here, for example, help us understood that some API in the system was broken, or even maybe unrelated to the changes. Maybe we had, I don't know, a storage issue, permission issue, sometimes which you change the user and permission in the database and you do it in the wrong way, or any other reason for that. So this helps us much to at a higher level to understand that we have an issue. So this dashboard is starting with high-level metrics that we would like to see every day. If I scroll down a bit, we have here two different widgets. One of them showing the distribution of error types over time, so you can imagine how helpful it is. And also a simple table that's showing us the top X. I don't remember exactly what is the number, probably 200 exceptions by type in the system. So we have the number of times the exception actually happened, and we also have the percentile of latency, which in many cases is very, very important, because in rare cases you have slowdown in the system that sometimes cause a chain of failures. So by experience, I can tell you that this percentile by latency helped us so much in many cases that we had to deal with issues in the system. Let me scroll down a bit further. So beside exceptions, which is the most important thing that we care about, we also want
So it looks like we might have a technical issue with Shachar. Let's give him maybe a few more seconds, see if he can reconnect.
Adam, can you acknowledge it to hear me?
Yep, you're back now.
Okay. Yeah, sorry about that. For some reason, my internet connection is not bounded to Kibana, so I cannot see failures. Okay, so beside errors, it's also important for us to track API calls in the system. Many times we had inefficient code base that was calling too many times to an API. So we use Kibana to also see the trends of API calls per endpoint. So here you have a widget that shows the trends, and here you have the widget that show the distribution of endpoint, number of calls, and etc. And then, as in every dashboard, once you scroll down, you also can see the raw data, the events themselves. So I'll show you an example of an investigation that we normally do when issues happen. So I'll just filter this connection failure exception and click on it. It will show up here. And I can quickly see that I had 132 exceptions of that sort. They all impacted this specific endpoint. And here I have the log itself. I can dive into the stack trace in the code and see the exact exception and get more details about what just happened there. This basically leads the developer quite quickly to the line in code, and he can start his investigation right from here, which basically most of the time save us so much time in at least initial investigation. Let me move to the other dashboard we have. So at Origami, we basically have a lot of API endpoints, mainly for getting data in, but we also have background processes that ingest a lot of data. This dashboard is one example. We're getting a lot of data, we're ingesting it, and a lot of things are important. For example, how much time it takes to ingest. And if it takes time, which part of the ingestion took time. Also, if things are failing, we want to know about that. So in this case, as in any dashboard that we normally show metrics at the top, just to get a sense of what's going on. So in this case, it's basically jobs that are running in the system. Each job has multiple tasks. So in this case, we had more than 1,000 tasks over 2,000 sources, never mind what it is, and 161 errors during that process. If I scroll down a bit, we have the distribution of tasks per job. It's basically like a function that does something. So we can see the trend here, the distribution here, obviously by the function name. And if I scroll a little bit more down, we have the same thing just for errors. So in this case, probably our staging environment has some gateway issues. Some services were failing. If I scroll down a bit more, we can see the distribution of our of the data that we're ingesting. The Origami, we're basically proactively fetching data, so that's why you see Facebook and Instagram, etc. And obviously, you can filter and get to the understanding of what failed and which job failed and which task failed and what error. So I'll do this thing again. I'll just filter this red gateway error. As you can see, everything is now showing only this exception, which quickly led me to understand that these services were impacted by that. These customers, sorry that I cannot show names, and these jobs, which basically narrows down my investigation to specific things. I can also look at, again, the code lines, the stack trace, and everything. Obviously, that's up to the developers to send the relevant logs. But this is very useful when you're investigating and looking for understanding if your system is healthy or not. Next dashboard. So this dashboard is basically a dashboard that shows replications of our data to our various data stores. At Origami, we store data in various data stores. Each data store knows to do different things. At the past, we always had discrepancy issues because we simply had a lack of visibility of the replication process. So yet again, as you can see, we have these templates that we're using just to simplify the lives of others that are using similar dashboards. And we can see the same things, the trends over time, the errors over time, and quickly triage and understand the impact, which is super important, especially when you care about your customers. You want to understand which customer was impacted by the outage that you had, and in our case, what data got lost and how to recover it. So we were talking before about being notified proactively. So with logs, unlike what we had before, using the logs alerts and events. So basically, it helps us get notification to Slack. We're using Slack internally, or PagerDuty when it's a severe issue. So with logs, we can, and I'll try to show you here. Yeah, just need to move this bar. We basically can define the query that we want. For example, in this case, we have a type of logs this type called file performance, and we're filtering errors. And we can define the trigger parameters. In this case, we're basically sending an alert on any error. And the action here is basically to send the notification to a Slack channel. Similar alerts are basically paging us, even if it's overnight. So that's that. Hopefully it was useful and valuable. And I'll hand over the presentation to Adam. Let me find it.
Thanks, Shachar. That was definitely helpful. And we're going to hand it over now to Ryan.
Can you guys hear me? Sounds
Yep.
Okay.
You're the presenter now, Ryan.
All right.
Okay,
I'm going to show my screen. Okay. Good. So it seems like I'm showing my screen. All right, good. So I'm just going to briefly show a slideshow quickly, and then I'm going to dive into actual the real data. So what we do at 8x8, I'm in charge of contact center, call recording, analytics, and the like, quality management. So we have a very wide range of products for telephony. So you can imagine the amount of data that we deal with. So I want to take some time and show you how we use Logz.io to solve some and answer some business critical questions. So slightly different than what you just saw. Why are we using it? Well, we're using it for user behavior analysis. We're looking at adoption trending and analysis as well. We have application performance metric visualization that we deal with, and the engineers use it too. So what are we doing and to basically enable those things? Well, we're looking at specific metrics around application workflows, so microservices and how things flow together within our microservice environment. We're using it for technical metrics and product metrics. So I will give you some examples of this briefly in the moments to come. And it's funny because actually it's not really logging what I'm going to show you. We use Logz.io in two ways. So we have the typical stuff like Shachar just showed you with server logging and Apache logs and things of that nature. Of course, that's all there. But we do something a little bit different and special with it. And that kind of leads to the how. So what we do is we separate our application logging into .log files. And again, those are going to be things from Java services, C++, things that developers care about, and operations guys. Additionally, we actually created, of course, there's many ways to ingest the data, and this isn't the form for that, but we created a separate log file, which is basically it's JSON. So we can be really specific on what it is that we're looking to capture. Now, I might add that this can be a little painstaking at first. It takes some time to get it right, but like anything else, if it's taking time and it's difficult, it's probably worth doing. So data cleanliness is a must. So how do you deal with that? Well, when you're building out your JSON, what you really need to do is take a look at all the fields that you're really interested in. And in my case, it was like 300. A lot of them have a commonality around them, especially in my environment where I have 6 or 7 microservices dealing with what we would call an interaction. That would be the beginning to the end of a telephone call. And those touch different microservices. And by nesting my JSON to be consistent across the microservices, I could form a holistic picture of what's going on, and I can literally follow a transaction anywhere that it goes. and that's important again for the technical aspects of it, and as well as some of the product metrics of it. So how do I do it, and kind of what are the other reasons why I use it? Well, one of the first use cases that I've used Logz.io for is COGS analysis. So this is, again, through visualizations. We collect metrics data about call recording storage. So this is just a simple use case. We're moving some of our stuff to S3 from an internally managed NFS. Well, what's the difference in COGS, right? So how would I calculate that? Well, it's simple. I basically need statistical numbers. So this is what the dashboard looks like. I'm going to quickly switch over. We'll see how this actually works. And I'm going to go ahead and find this example for you guys. And this is the one. So this is an example of my alpha environment, just internal testing stuff. And here I can actually start to pick up specific metrics around how people are using it, how many hours, how many objects do I have. So there's many, how many transcriptions, because I am transcribing, voice recording. So in this environment over 7 days, I can obviously see the spikes where people are sleeping. I could see where the types of media that I'm collecting. I could see where the media is being collected. I could see how many people it's collecting it from. How many people or how many physical objects did I get, and how many hours. So quite effectively, and I could even go down to the individual object level. And of course, all the filtering and everything is consistent with Kibana. So Shakar showed you how things are filtered. That all works the same way here. So for me, I'm able to figure out my COGS easily. Literally, I can tell you, what type of storage one particular person utilizes. And then, of course, I take a lot of this offline and run the basic math against it in something like Excel. But this gives me the holistic view and gives me the ability to literally export this data if I want to right out of Kibana and then do some calculations. So that's use case number one. I know we only have a couple of minutes left. I'm going to go through and I'm just going to present to you really quick on use case number two. So we'll load the slide. So this was the bottom line stuff that I talked about. So adoption items. So this is another use case. And just so you know, there's probably 30 use cases that I use this for. But in this example, we have a feature customers paying for, and they're not using it. Well, why? Unfortunately, Logz isn't going to give us the answer to that, but it will present us the data that allows us to make better, more intelligent decisions about how we're promoting the product, how we're selling the product, things of that nature. So again, we could see it happening. We could find a pattern. We could find a trend. So let me show you what this looks like. And again, for speed and ease of use, I have this set up. So so here's an example. This is again my internal site where I can see that I have a particular product that might not have the level of adoption that I'm looking for, and I want to answer that question. Well, why do I have 260 people using my base product? They've purchased an upgrade, but only 20 people have effectively installed it. So I want to know that, right? So I can use this to look at adoption all the way down to specific features, right? I picked this one as a simple example, but by taking use metrics out of my application and putting them into JSON, or if, in fact, anything that you want to measure and putting it into JSON gives you the opportunity to create a visualization on it. If I build a new feature within the application and I want to understand how people are using and adopting it, I could simply tell my developers I would like to have a metrics export. Here's what it is. When I deliver the requirements, they put that inside of the JSON format, and it simply automatically adjusts, and boom, now when they push to production, I now see metrics about my new feature. So that's feature analysis. Let me give you one more quick use case in the 2 minutes that we have, going back into presentation mode. So that's, again, I showed you the adoption dashboard. Use case 3, I figured know your audience, so I wanted to put something in where I could show you how not only are we using it for business metrics, but we're also using it for technical metrics as well. So using the same philosophy that I gave you, I can look and see, I can discover services underperforming and take action. Well, why are they underperforming? Well, maybe there's not, maybe auto scaling isn't configured correctly, or in the case that I'm about to present, there was some logic within the application that needed to be addressed, and it was very, very computationally heavy and looking to optimize it. But you want to see it in the wild, and you want to optimize it in the wild. It sometimes behaves differently under load, obviously, than it will within the lab. So I'll show you a little bit of that dashboard and how that works. I believe it's this one. Okay, so in this case, I have a service that's running, and what this service is actually doing, it's quite a nifty service. What it does is it takes transcriptions, speech to text, and it categorizes the words that are said into what we call topics. So if I was to say something along the lines of, I'd like to place an order, right, I might categorize the language in that call as, order entry or something like that. So this service is very computationally heavy because it's basically using natural language processing to figure this out. And I might simply want to know, how long is it taking to actually make those matches, right? So I can see all the way down, and of course I nest all my objects all the way down to the customer level, so I can look and see what particular customer has been using it, when the last time they actually, tried to add new topics and reclassify them, which is computationally heavy, and how long it actually took. In this case, we've seen this spike to 5 hours. And what's wonderful about these metrics, think about them on an individual basis. All of these, using Logz.io alerting system, can alert you when something is outside of the average, right? So these metrics not only are great for visualizations, but you can use them as baselines within Kibana to figure out, okay, if this goes above some particular value, well, then message me. I had one case where one was broken and it kept coming as zeros. Well, I created an alert telling the DevOps, hey, when this hits 0, please go fix my problem. So that's basically it. So it's not only logging, as you can see. It is very, very useful for several other things. So with that, Adam, I'll pass it back off to you.
Okay, it's on my screen now, and we're good. Okay, thanks, Ryan. Thanks, Shachar, very much for showcasing your cases. We'll go ahead. I just want to quickly ask you to let us know what you want to see next and suggest us what you would like to do in the next webinar. And before we wrap up, I want to quickly recap what we learned today. So basically, we learned about bucket aggregations, and we learned about the filters, how to add queries. We learned about the gauge, how to create, how to apply the bucket aggregation to the gauge and see different time sets there. And as always, I would like to thank everyone for joining. And part of being a customer success team member, this is exactly what we want to provide to our customers. Please do not hesitate to contact us at any given time. It is our job to take your data, make it meaningful for you, and then create dashboards and visualizations and alert, and just extract as much value as you can from your own logs. This is the customer success team. Thank you very much. Have a pleasant evening or morning, depending on where you are. Thank you.